All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's us. We're back hosting the Show and Tell. Thank you very much to Melissa and JP and Liz and other people who have been hosting Show and Tell the last couple of weeks. But we're back, baby.
We're back.
Lady Ada, Mr. Lady Ada. But right now, we're going to check in with people around the Adafruit community, including some Adafruiters, people who we fund to do projects and more. See what's on their desk. What are they doing? Come on by. We're in Discord. We're in StreamYard. The link is in Discord. You can.
Yeah.
All you use webcam. Come on
This
by.
is your chance to see a lot of behind the scenes of what's going on in Adafruit, some of the projects we're working on.
We want to see what you're working on too.
Yeah.
Okay.
All right.
Let's start with
First up is Brent. Brent, what you got going?
Hi. First I'll show. Maybe we'll do a little bit telling, and then we'll do some showing.
Yeah.
My main job at Adafruit is working on this firmware called Wipper Snapper. It can make any like Wi-Fi capable board into an IoT device without programming. We wrote Wipper Snapper's like communication API, so like how the device talks to the MQTT broker over the span of like a couple years, and everything's in this like really good state right now, and we're almost ready to rip the beta tag off. But we needed to make some significant changes to like how the devices talk to Adafruit IO to help us go forward with the project. We want to add new features, so like low power modes, TFT displays, offline SD card logging, GPS over UART, and make it easier to maintain too. Like this is getting kind of unwieldy. So the team's been writing a new version of the API, like a V2, and Lady Ada said like, hey, we can finally develop this Python client you wanted because it's like faster to develop than Arduino and C++.
2-in-1.
2-in-1. So actually we're getting like 3 or 4-in-1 now. So Wipper Snapper Python we're working on, which is exciting. And it uses this Blinka library that Melissa wrote. And Blinka translates CircuitPython code into like the hardware layer. And it lets you use CircuitPython code in desktop Python. So you can support single board computers like the Raspberry Pi. So you can get Wipper Snapper running on the Raspberry Pi, which is exciting. But it needs a board attached. And since this is a major API rewrite, we need a way to run tests on the Wipper Snapper Python client without attaching hardware. So like we want to run this client from either like a Raspberry Pi with no hardware attached at all, or like the GitHub Actions server, and just like test it out and exercise it, make sure things are working properly. And then like the current Wipper Snapper, like we have no tests on. It's just like functionally, do things work, do things not work. But now when we start building on these new features and adding features, we're going to be able to test them before we release them. So in order to do this, I've been working on mocking out the Blinka library that Melissa wrote with stubs for CircuitPython function calls, so we can call CircuitPython code, but there's no hardware attached. So like we can create a digital input without a board attached, and it will return like a value that we want for testing. So I'll show this. It's not like an amazing show because it's a terminal, so we could switch to that window.
Okay.
And in order to get this working, you would have to set 2 environment variables. Like one of them is Blinka force chip, and that tells Blinka, hey, we're going to simulate the MCP221 chip, and then the other is Blinka force board, and that says, okay, we're going to use this board. But what it actually does is it tells the Blinka layer, like, we're using this chip and this board without hardware attached. And now, like if I go into Python and I type import board, it will work with no hardware attached. Usually it like returns a crazy error. And if you do board dot and then hit tab, it will show all of the pins from the microchip MCP221 breakout that we sell. So an example of like returning digital input, we could do like digital in.py, and this will return an alternating value that always starts at true and then goes to false and then goes back to true. So like the code is just like CircuitPython code, but it's running without hardware attached, which is really neat. And I don't know if we've been able to do this yet. And then another one would be analog in. So we have just an ADC set up on like the pin G1, but there's actually no board attached to it. And we would do analog.py, analog in.py, and that will return like a random integer. What we don't have right now, which I need to add later this week, is the ability to tell it through like I kind of like this environment variable thing that we're like, hey, we're using this board, it's not actually supported. So I want to be able to tell it like, hey, we should actually be returning this ADC value, but without passing it the value explicitly. We also, to get I2C working, we mocked out this BME 280 library for CircuitPython, and they replaced and stubbed out the property calls for like temperature, humidity, and they actually call the Open Weather Maps API. So calling this is actually getting data not from a sensor, but from the internet. So it's like realistic, arbitrary data. It's not random data. It's calling an API, and the code for this just like looks like CircuitPython code. There's no like weird overhead or there's no text fixtures. This is just CircuitPython code that's running without hardware attached.
Okay. Yeah, this is going to be
Very
interesting
cool.
because as we start doing more testing of Blinka with Whipper Snapper, being able to mock all of the interfaces so that we can test the protobuf part, the internet connectivity part, the web part, without needing to like actually wire up hardware. We can assume that the hardware works because like that's tested separately. This lets us, do tests on Whippersnapper. I think it'll be really handy for also Lauren, who does the backend development on Adafruit.io and like Adafruit.io in general, right? Like people, if people are having an issue, we can try to replicate it and then not require the hardware to do so. It'll be a lot easier to figure out what's going on.
Yeah, it'll be great. We can just like isolate any issues people have.
Okay.
Thanks for that.
Cool.
Alrighty, next up, we're going to go to Jepler, then we'll go to Liz and John Park, then DJDevon. Jepler, what's going on?
Hi there. Well, I've got just your very basic standard sand demo, and you've seen this before, but what's interesting about it today is I've upgraded it to work with the upcoming, Lamar can tell me if I'm saying this right, it's the Arduino ESP32 board support package version 3.
Yeah.
They changed some of their APIs just to keep up with ESP IDF, and some things changed that Protomatter depended on, and I got the opportunity to untangle that. And now the practical impact is all of your Protomatter sketches in Arduino are going to just continue to work when that update comes out as stable.
We got NeoPixel going, and we had a bunch of other things that we needed fixing, but this was the one that was like, I spent a couple hours on it, and I was like, I can't really focus and figure out what's going on. And I figured you had done the Protomatter port for IDF5 anyway, so it's like, you probably like know more about this stuff. So thanks for jumping in on the Arduino library.
There was definitely some head scratching on the way to having the solution, but it seems to be really solid now. So that's great news.
Thank you so much.
Thank you for making this open source as well.
Yes.
We'll be playing the video in our open source section and Ask an Engineer.
And if you've never tried this demo, this is a lot of fun. I could just sit here and do this.
Yes. It's all fun of sand without getting sand all over you.
It's bouncy sand, and it doesn't get in between your toes and all that stuff.
All right. Thanks so much, Jeff.
Okay. Thank you, Jeff.
All right, Liz, what you got going on this week?
Hey, I have a disembodied rectangle here that is running on a Pico W on a Pi Cowbell doubler with a Pi Cowbell DVI. And so it's putting out DVI data. And so that's how we're getting the display here. It's going into my graphics card. But what's happening is it's pulling down feeds from Adafruit.io. So at the top, we've got an AQI. We've got a battery monitor for the board that's running with all the sensors, and we have humidity and temperature data. And this is coded up in Arduino, and it was a collab I did with Pedro this week, and Guide went live. So you can edit the code so that it has your feeds and your I/O data, and you can have like a nice display that you can pop up on an HDMI display, either a little one or your TV, or maybe you want to have it with your webcam, like how I'm doing right now.
I think it's cool. I like the chunky look. And we were, we were planning out, behind the scenes, me and Liz were planning out maybe doing a teletext project because it had this like real teletext feel. And I wanted to reproduce one of the first projects we did, which was the YBox 2.
I remember that.
I remember that. And it would connect to Foursquare to get local event data. And I was like, man, it would be so cool to like be like 15, 20 years later, let's redo this project, but do it on a Pico W. So it has like, it actually is like a lot easier. It doesn't use Ethernet. It had like bit-banged Ethernet. Where you could use Wi-Fi to get local data and display it on a TV. And then it has to play tubular bells because teletext always plays tubular bells.
I think this is a good idea for when you want to have a smart TV, but not have it listening, doing things, subscription services. You can kind of turn that canvas into whatever you want. And this is a good one. It could be an ambient device that's there at all times without the all you have to give up for getting a little bit of data.
Yes. And I used to work in higher ed, and a big thing with higher ed is digital signage. And folks are always trying to find out ways to like display exactly what they want and do more open things. So I could definitely see stuff like this being used in that context.
All right, Liz. Well, thanks so much. We'll be going over the guide and more this week.
Oh, you know, actually would be really good. Now like I'm thinking about like what would be really fun is you know, because I was thinking like Foursquare, I don't think exists anymore. You know, or Dodgeball or whatever.
The data service does.
Yeah, but maybe we could use a Google Calendar because remember we had a Google Calendar interface. Maybe we could just show what's on your calendar for the day. That could be kind of
that'd be really cool.
Maybe we'll do that instead because I know we did some CircuitPython code for MagTag. Okay.
Nice.
Alrighty.
Have a good one.
Thanks so much.
Thank you.
Okay, JP, what you got going on this week?
Hey, so I have this humble little thing right here, which turns out to have saved the day. This is a little teeny tiny USB-C breakout, and it is a simple one because it's just got kind of what you expect from B and micro and mini, which is just ground, power, data minus, data plus. All I needed was data minus, data plus because I am trying to charge a battery inside of a PlayStation controller. So this is a regular PlayStation, the first generation controller. And I am making a wireless version of it using our little itsy bitsy ESP32 there. And I don't need to program it while it's closed up. In fact, I've got it set up so that I can do that over the air using Wi-Fi, which is super rad. But that means that when it's closed up, I want to, using a little charger that's under that battery there, be able to charge up this LiPo battery. So fitting this super minimal little nub of a USB-C port up in the top here, and I just take away a little bit of plastic there, means that I can close this up. Actually, before I do, I'll show you it work. If I plug in the USB-C cable, I've got light. That means that I'm charging this up, and that's all I need it to do. And that's just soldered to 2 pins in the project. When I close it up, it is protruding nicely there. And I just actually used some super glue accelerant and super glue to glue it down to the board, the back of this sort of PCB that was already in there. And I put a little Kapton tape on there also just for good measure to prevent any shorts. But this is great because I was trying other ones and they don't kind of have a PCB that runs all the way up to the end. This one, since it's so minimal, and I saw actually, Lamore, in your product description, you said you'd found that people were using these to add charging in their keyboard projects.
Yeah, it's like somebody asked me to carry it, and I was like, well, like I don't quite get it, but like it's
now we know.
You know.
Yeah, it's perfect for these kind of things where you're like, there was never meant to be a USB cable and plugged into this thing. And I don't have a lot of space, and I don't have a lot.
Well, you're using something like I've never used. I was like, I've never really used it, so it's like cool.
Worked out great. I've charged it off of a hub. I've charged it off of a battery, so I don't know what it'll do if I try to use a power delivery hub. It might just. It
may or may not work depending on whether the power delivery hub cares that there's nothing. On the other, that's the only problem with these is like I do want to like this is I don't fab this, but I do want to make a version that I fab that does have the proper power delivery resistor. So maybe I'll do that next.
Yeah, but for this little small battery, just needs to be charged kind of overnight, sort of thing. This has worked out great, and I'm super happy with it.
All right, cool. And you'll probably be showing this off tomorrow on JP's workshop.
Yeah, I'll be showing this and a Mondo big game controller project that's going to get started using this ridiculous beast of a controller. So come by if you want to see the innards of this and some modernization going on. So I'm going to drop it on my foot and break it.
Careful. All right. Okay. Well, thanks so much, JP.
I think it's like JP's retro workshop. It's like this Nintendo. There's somehow you have 3 Sony Trinitrons.
Yeah.
It's a mood.
I know. Well, once you have them, you want to stack them because you're like, I want to be like a network TV.
Stackable. Yeah. It wants to look like an old TV station in here.
Yeah.
All right. Thanks so much, JP.
All right. Thanks,
guys.
JP.
All right. We're going to wrap it up with DJ Devon. Take it away.
Hello. Can you hear me?
Yeah.
Okay. Last week I said I'd come back on and show off the GitHub API project that I've been working on that pulls the latest 25 closed PRs from GitHub for CircuitPython PRs. So these are all basically closed bugs. And it was a nice segue from JP with this little USB thing because I need like a little USB adapter. So I will show you what's on the inside. This is an enclosure that I 3D printed, and it's using a panel mount for USB. And this has a right angle USB plug that plugs into that. But this cord is so thick that when I try to go to close it, it won't close because this cord is too thick. Yeah. So I need like a ribbon cable kind of USB panel mount solution that's thinner for tiny enclosures. This enclosure is about half the size as the one that I was using, and I did not account for how thick this cord would be. And this is running on a Feather. And this one is the same exact demo, same case, same enclosure and everything, but it's running on a little Cutie Pie.
Oh, so cute.
So this has got a Cutie Pie that is powering a display, SD card, and a touch controller, which I don't have the touch demo working, but I assure you it works.
Yeah.
So that's what I've got.
Nice.
GitHub API 3D printing enclosure stuff.
I love that you got the little icon of the person too.
That was not, I figured out this week that you cannot upload BMP avatars to GitHub. And if you upload a GIF avatar to GitHub, it will automatically convert it to PNG. So you're only allowed PNG and JPEG. And unfortunately, CircuitPython doesn't have full PNG support. So as you can see, I'm displaying a default Octocat instead of the person's actual.
JPEG probably,
They actually do. So if you want to show up on my sketch here, go into GitHub and switch your avatar to JPEG.
Yeah, if you want DJ Devon's project to work. Okay, well, looks good. All right, keep coming back. Give us updates as you figure out your enclosure stuff.
Thank you. Have a great day.
Thank you. Okay.
All right, that's our show and tell for the week. This week, we're going to get set up for Ask an Engineer, which starts at 8 p.m. We're every single week, 7:30 p.m. Eastern Time. Show and tell, come by, show and share your projects, and more. Thanks for making this the best half an hour-ish, 20 minutes-ish of the week every single week. We'll see everybody next week. Bye-bye.
Thanks, everybody. See you in a few minutes.